Okay, so we are moving on with deductive reasoning. We've already talked about inductive. Now I just want to go back here and we're going to talk about conjectures again. I just want you to look at those two separate shapes up there. You don't have that in your notes. But what do you notice? The question would be, so here's one shape, here's the other. What do you notice about the center circles? What would you say? Which one's bigger? Yeah? They're both the same. But doesn't this one look a lot smaller? And if you take a ruler, ruler just got crazy on me there here. Okay. If you take this ruler here and you measure, do you see it's just a little over 2 centimeters? And you come over here, just a little over 2 centimeters. Proves to you that this circle here is identical to this circle. Okay? So sometimes we make conjectures without testing them enough, right? And when you do that, okay, now what can you make about the conjecture about the lines on this? What do you think? They look curved? Or are they straight? It looks curved to me when I look at them, right? But again, if I was to like bring a ruler up here, look how straight the lines are. Yeah, it's messing with your head, man. That's what I'm trying to do. What's the conjecture about the number of triangles? Yeah, not closed. But I guess you could assume this one here is like one triangle. Okay, so this is just talking about, again, conjectures, right? So what we did last class and even well, just on the quiz, but inductive reasoning is just based on observation. Okay, so anything like, the first time I lent the money, he didn't pay me back. The second time I lent the money, he didn't pay me back. Third time I lent the money, he didn't pay me back. So, he does not pay back his loans, right? That is a conjecture, okay? It's not based off formulas or science. Are you with me here? Are we on our phones? Now, inductive reasoning can never be used to prove a conjecture, okay? We have to do that mathematically. Because even on the quiz, you know how you could keep coming up with examples? Unless you gave every example in the world, it's not true yet. And that would take you forever. So there's got to be a better way. And that's where we use deductive reasoning. Now this is using logic to reason. Okay, so I just want you to, this is back in the day, this is probably, maybe you remember this, maybe you don't, but there's a time where Susie dropped off her photo at Quick 1 Hour Photo. Quick 1 Hour Photo advertises that if your film is not developed within the first hour, there's no charge. Susie dropped off the film at 10 o'clock and it wasn't developed till 11:15. What can Susie deduce from this information? What can she deduce from this? she will get her photos free. Okay? So, this is a factual statement. If your film is not developed within 1 hour, there's no charge. That's fact. It's on the sign. Okay? She dropped off at 10 and it wasn't done till 11:15. That's a fact. Now, if both of these facts are true, then what can you say? That it must be free. She is not going to get charged. Okay? So, the deduction, we say, from deductive reasoning is that Susie's film will be developed free of charge. So if I could make a deductive statement about this Tuesday. So if I said statement number 1, you do not have to come to school on PD days. Statement 2, Tuesday is a PD day. You would have to use deductive reasoning to not come to school. Because if you didn't know either one of those statements, if you truly didn't know either one of those statements, if you didn't know you didn't have to come to school on a PD day, wouldn't you come? If I said, guys, it's a PD day on Tuesday, you would come, wouldn't you? Because you didn't know you weren't supposed to come on PD days. So you don't even know it, but you make that deductive reasoning jump all the time. Okay? Now, for those students that can't make it, right, Mr. Fox comes on the intercom and says, okay guys, Tuesday is a PD day, you don't have to come to school. Okay? Just because always, and it's every year, no matter every PD day, there's always one student that comes to school. And they're like, where is everybody? I'm like, it's a PD day. What? Oh, okay. And they go home and they're kind of happy and they're kind of mad because they just bust all the way here. Okay? So, now, inductive, right? It happened, it happened, it happened, it happened, it happened. It's going to happen again. Deductive, statement 1, statement 2, and then I make. So they're very different. Okay? So, deductive reasoning is what we also call logical reasoning. Like, if your parents say, don't touch the stove, it's hot. Okay? I guess they could say, okay, when the stove is on, it's hot. And when you touch hot stuff, it really hurts. And then you would go, I shouldn't touch the stove. That's deductive reasoning. Okay? Now, if every time you touch the stove, you get burned. 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 Then you go, wait a minute. If I touch the stove again, I'm going to get burned. That's inductive reasoning, right? You just, the pattern. Now maybe the next time the stove's off, but you still might assume it's hot. Okay? So, also called logical reasoning is the logical process of using true statements. Now this is very, very, very important. The statements themselves must be true to arrive at the conclusion. Okay, so someone says, when the stove is on, it's freezing cold. Okay? And then the next thing, when you touch hot things, you'll get burned. Right away you're like, I'm missing the gap. I'm missing the, like, why? Because doesn't the stove, isn't it hot? Like, why is it cold, right? So, well, right away the deductive reasoning's out of the window because statement 1 was false. Okay, and we'll get into some of these as you'll start to see. Now, so please evaluate the statements before you make the conclusion. Like I'll give you this example, okay? So let's say you're 2 years old and you're looking out and there's a building on fire, okay? And you notice that every time a fire truck comes, the fire's bigger. So then you make the deductive reasoning that the more fire trucks that come, the bigger the fire gets. Now, that's not false, but usually an adult would say, no, 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 no. What happened was the fire got bigger and bigger. Therefore, that's why more fire trucks came. Now, that may be an obvious example, but some people mix up the two. And they don't know which is the chicken and which is the egg. Okay? They don't know which one is the one causing the other one. Okay? But I think we both know that the bigger the fire, that's why more fire trucks come. But maybe, and I don't know if you ever watch shows and they're comedies and there's aliens on one and they're always trying to figure us out as human beings. They make statements like this that sound ridiculous. And then you kind of think about it, yeah, I guess if you think about it that way, yeah, the more fire trucks come, the bigger the fire gets. I get that, but that's not really what's happening. The fire got bigger, so they needed more fire trucks to put it out, right? There's always that explanation part. Now let's just talk about these, okay? Now, write a conclusion that can be deduced from the pair of statements. Now, every whole number is an integer. 6 is a whole number. Now, first of all, let's just talk about this statement. Every whole number is an integer. Now, a whole number is 0, 1, 2, 3, ... Remember? They're your counting numbers with 0. Integers are ... -3, -2, -1, 0, 1, 2, 3, ... Now, is every whole number an integer? Do you see how every whole number is in the integers? Okay, so let's put a check mark and say, I agree with that. Now, 6 is a whole number. Do you agree with that? Okay, because if we kept going, 4, 5, 6, there it is. So what can I deduce now? What else can be deduced? Yes? 6 is an integer. Okay. Water freezes below 0 degrees. True or false? What do you think? True? The temperature is minus 15 degrees Celsius. Well, we'll trust them. Okay, maybe it is. So what can you deduce now? The water should be frozen. Okay, so this is really important here. A theorem is a statement which can be proved using logical or deductive reasoning. These are the same thing, right? Logical and deductive, same thing. They're synonyms. Now, let's really delve into why inductive and deductive are different. Now, in lesson 4, we used deductive reasoning to write a conjecture The sum of 3 consecutive integers is divisible by 3. Okay, so if you remember this, let's just write example 3 plus 4 plus 5. This is 3 plus 4 is 7. 7 plus 5 equals 12. It says it's divisible by 3. And if we try anything else, 4 plus 5 plus 6, that equals 15. 15 is divisible by 3. And remember how we said that, hey, if we take 1 away from here and give it to this one, we would have this, 5 plus 5 plus 5. Well, then all 3 numbers are the same. So if you added 3 identical numbers together, divide by 3, you should get that number back, right? Now, this is not a proof. This is inductive reasoning. If you gave me example after example after example, that's just a conjecture. That's just inductive reasoning. We need to prove it. Now, I'm going to show you how to do these, and they're going to maybe not seem that easy at first, but the more you do them, the better they're going to get. So what we're going to do is I'm going to call the middle number n. Okay? So if n is the middle number, what would we call the number before that? If the middle number is 8, how do you get the number right before that? Because the number before 8 is what? 7. What do you do to 8 to get 7? Take 1 away. So if the middle number is n, wouldn't the first number be n minus 1? What would the number after n always be? N plus 1. Okay? Now, let's add these together. Let's add n minus 1 plus n plus n plus 1. So this would be the same thing. We would go n plus n equals 3n. And then we have a negative 1 and a positive 1. What happens when you go negative 1 plus 1? It's 0, isn't it? So look how it's 3n. Is 3n divisible by 3? Yeah, because if I divided by 3, I would get n. So there's my proof. This is proven using deductive reasoning. Okay? Now, I know when my one son was younger, he'd always be like watching YouTube, and he would hear these, he'd get these weird riddles, and then he'd like, okay, Dad, take this number, do this, do this, do this, do this, and then he guesses my number at the end. Okay, has that anyone ever done that to you? Okay, well, let's do this one here, and let's try it. Choose a number less than 10. Sure, you want 9? Going for the big one. Okay, add 7. What's add 7? What is it? Talk to me. 16. Multiply by 2. Subtract the original number. $23, right? Subtract 2. Subtract original number. 12. Okay, now this isn't the thing, but you're supposed to do this all in your head, and then someone goes, you got 12. And you're supposed to be freaked out because they're like, how would they know that? Anyway, let's try another one. Huh? 4. So let's circle it. Add 7. 11. Multiply by 2. 22. Subtract the original number. Subtract 2. Subtract original number. Okay, let's try another one. What's another one? It's got to be between 1 and 10. Let's try 7. Yeah, let's try 1. Right? Maybe you're like, okay, he's going to make me do a bunch of stuff in my head. I'm picking 1. Okay? Add 7. 8. Multiply by 2. 16. Subtract the original number. 15. Subtract 2. Subtract the original number. Now, if someone just comes up to you and does this, like, you think they're magic. You think they're a mind reader. Okay? Now, through inductive reasoning, and we could do more, you'll see we'll always come up with 12. But left to inductive reasoning, it almost feels like magic. Like, you're awesome. I don't know how you're doing it, but you're doing it. Let's talk about it as deductively. Okay? So let's call our first number x. Okay? If my first number is x, and I added 7, what would it be? X plus 7. Now what if I multiplied it by 2? Now be careful here, everybody. You're going to multiply the entire thing. Right? It's all multiplied by 2, which gives you got to multiply that in. That's 2x plus 14. Now, what are we going to do to the next one? We have to subtract original number. So we have 2x plus 14, and we're going to minus x. Wasn't x my original number? So what does this become? Let's put an equal sign at the end all the time. What's 2x minus x? 1x plus 14, right? Remember, we just subtract like terms. Now we'll start with our new number, which is 1x plus 14, and we're going to subtract 2, right? What do you get? What do you get? 1x plus 12. Okay, so write that down at the next one, 1x plus 12. Subtract original number is what? Minus x. What do you get? What's x minus x? It goes away, leaving you with what? So I've proved it using deductive reasoning because x can be any number in the world. So after I've done this, it's not such a magic thing anymore, is it? Okay, guys, does this make sense? Now, we have proved that whatever the original number is chosen, the final answer is 12. That's deductive reasoning. So, does the original number have to be less than 10? No. Would it work with a negative? Let's try it. Yeah, that'll work. Okay. So let's come up here and let's do it in a deductive case, and let's use -1. So -1, if you add 7, what would you get? 6. Multiply by 2. 12. Subtract original number, so you have to go 12 minus negative 1. What do you get? 13, right? Those two negatives make a positive. Subtract 2, get 11. And then subtract original number, 11 minus negative 1. So it works for negatives as well. Has anyone ever done this to you before, ever? Yeah? Okay, so here's some other things that we need to know as we're learning how to do these, okay? Now, in this lesson, involving odd numbers or even numbers, 2n always is an even number, because if you multiply anything by 2, it makes it even. No matter what you give me, if I multiply by 2, it'll be even. If you give me 5, 5 times 2 is 10. If you give me 4, 4 times 2 is 8. So if it's an even number, I multiply by 2, it's even. If it's an odd number, I multiply it by 2. Now, same thing, 2n minus 1 will always give you an odd number. Or 2n plus 1 as well. Because 2 times any number will be even, correct? Plus 1 has to be odd. Right? Odds are 1, 3, 5, 7, 9. Okay? Now, explain why 2n can be donated to use to represent any number. Well, 2 times anything is a multiple of 2, which has to be even. It's a multiple of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So when I take something and multiply by 2, I've automatically said now it's a even number. Now 2n minus 1, if you take any even, right, which we've already accepted as 2n, and minus 1, it has to be odd. Okay, so now we're really going to see what's the difference between inductive reasoning and deductive reasoning to solve the same problem. When two odd numbers are added, their sum is always even. Okay, so let's use inductive reasoning. Just give me numbers. Give me a case. No, I need two odd numbers. 3 plus 7 equals 10. When two odd numbers are added, the sum is even. Okay, that one it worked. Give me another one. I need 3. Good. Another one. Okay, so that's using inductive reasoning. Now you can stick with inductive reasoning your whole life, but it becomes very tough and because now to disprove it, you always have to see if you can find a counterexample. And counterexamples are not as easy as you think. Even from today's quiz, right? Some of you could not find a counterexample to disprove that. Same with the court of law, okay? Even though you may know this person, because you're innocent until proven guilty. So this person is innocent, like, you know, you're pretty sure they murdered the person, but until you give proof, that's that one counterexample to show they're not innocent. That's the court of law. And if you can't find a counterexample, too bad, they walk. Okay? Now, let's use deductive reasoning. Now, 2n minus 1 and 2m minus 1, because n and m are going to be your different numbers. Now, according to this, if we add these two together, it must be an even. So let's try it. Let's go 2n minus 1 plus 2m minus 1. We could even put it in brackets or underline it if you want. Those are my two numbers. Now what does this equal? What's 2n plus 2m? You can't add them. That's the best you can do. But you can. What's negative 1 and negative 1? So if you had a negative cowboy with one bullet, it means another negative cowboy with one bullet. They're on the same team. They're not going to fight. So the negative cowboys would have 2 bullets, right? Now, and you should be able to remember this from last year. What's a GCF of these three things? What can I factor out? What can I divide out of all of them? 2. So if I take a 2 out, that's n plus m minus 1. Now I've proved that two odd numbers added together always equal an even number, because whatever this equals, what happens when I multiply it by 2? It has to be even. So no matter what, n and m and the minus 1, after I multiply it by 2, I guarantee it'll be even. So 2 times anything is even. Okay? Now, we're going to be doing 1 to 3, but what I want to do is I just want to go to the next, I want to just talk about the, so 1, these are very good, especially, so this is where we really want to step up working on the whiteboards, because these are conversations and writing them out. This is talking, you got to talk through this. If you're sitting at your desk and, you know, like we're off to a good start. So we're exactly where the class was last year at this time. What? Oh, I didn't write down my average. I think we're at like 78 average or something in the room right now, right? Just a little below 80. But the first unit was kind of like people were getting into it. This is stuff where people really started to take off more because they were discussing it, they were talking, and they remembered it for the tests. So this stuff here, right, I want, what conclusions can you make from these? Now, number 2, I want you to stop. So don't do this part. Okay, so you want to stop here. After you subtract the original number, just stop. I mean, it goes on for so long, it's like, okay, whatever, man. Okay? Now, I do want to just kind of help you with 3. It says use deductive reasoning to prove the following statements. And students kind of struggle with this right from the beginning. So I'm going to help you out, because 3 consecutive numbers, 3 consecutive even numbers, that's not 1, 2, 3. That's 2, 4, 6. That's 8, 10, 12. They're consecutive even, but how do you write that like with ends? So you let 2n equal the first number. Now what would be the second number? If 2n is the first one, what's going to give me the second one? Okay, so this is good thinking. I don't want to give this away. So if n, say, equaled 1. Okay, so my first number would be 2, wouldn't it? 2 times 1. How would I get the next one? Okay, I'm going to actually use a different, I want to use 5. 5's a better number, because 1 kind of sucks for what? 2 times 5 is 10. That's my first number. Now what is my next number got to be? No, consecutive even. It's got to be 12. And the one after that? So what? So if 2n is my first one, what would be my next number? 2n plus 2. Very good. So let 2n plus 2 equal the second number. And what would be the third number? 2n plus 4 equal the third number. Now you're going to have to come up with the equation and you're going to add them together. So you're going to go 2n plus 2n plus 2 plus 2n plus 4, and you're going to see if it's divisible by 6. Okay, so you're going to keep going with it. I don't want to do that part for you. Okay, so I'm just helping you do your let statements so you can get used to them. Now, the sum of any 3 odd numbers is an odd number. So what would be my very first number then? Has to be an odd. 3 odd numbers. The first one has to be odd. So what could I call it? What could you guarantee the very first number would be odd? And I can put any n in and it will be odd. So if you let the first, some people want to let n equal the first number. But then what if I give you 4? Okay, I'm picking 4. Well, you can't do 4. Well, n's supposed to be any number in the world. I'm supposed to be able to give you any number. Look at, let n be the first, or let 2n be the first number. I could give you any number in the world, and it will be even. Because 2 times 5 is 10, 2 times 22 is 10, or 44. They're all even. What could I give, what would be the very first number that I, and guaranteed would give me an odd number? n minus 1. Now, for this one, I should have said first even number, second even number, third even number. So this would equal the first odd number. And you could try, give me any number. It's got to be an integer. Give it to me. 3. 2 times 3 minus 1. That's 6 minus 1. That equals 5. Yeah. You can give me any number in the world. This would be, this will always give you odd. Okay. Now the next one, what would be the second odd number? Oh, no, sorry. We're doing the sum of any 3. So what would be my second odd number? So give me another odd number. See, this gets tricky, right? We want it to be maybe a different number, so we're going to call it 2m minus 1. And then let 2p minus 1 equal the third odd number. Okay, now again, now you're going to have to go and add them together and see, is it truly an odd number? Okay, that's the math that I want to see. So I'm very curious in walking around and looking at your boards to see, are you getting this stuff, right? And then C and D you should be able to do from. So not a lot of work today, but it's really important stuff, okay? And so I'm going to hand out cards. I want to encourage everybody to have a partner and just go through it, because even these first ones, right, you don't have to be writing down, right? You just have to be like, okay, Leona lives in a 100-mile house. 100-mile house is in British Columbia. What can you deduce? Leona lives in BC. Flip. Yay, we're right. Then go to the next one, right? So talk about these. It's not all about writing it down, right? Are you using your deductive reasoning to come up with the, and then this one I want to see, can you come up with the equation to show, because we'd have to see what that number is all the time. Like I hope you're doing this 3 times, getting the same number, then you're going to come up and do it algebraically. And it's pretty satisfying when you get it algebraically to show. Because when my son kept doing it and doing it and doing it, he didn't know why, right? So I just pulled this up, or not, I didn't pull this up, but I just wrote it on a piece of paper, and then he could get it, right? And that's where we always want to be. We want to be deductively, not inductive all the times, because we just do stuff. We don't know why. It's kind of cool. It works, but why? Like, and when you're in that why territory, then that's good stuff.